Good afternoon, everyone. Can you hear me okay? Yeah, good. All right, so this workshop is intended to start at 3:15. You might notice it's 3:16, and the room is not quite full. I think the raffle is still going on in the main hall, so it must mean that you care more about learning about application automation than winning something amazing from one of the sponsors. So thanks, I'm glad. Yeah, that's cool. It's cool. And so it's, for me, from my perspective, this is an awkward time because there's the question, like, do we wait for more people to show up because we don't want them to get left behind? Or do we say, screw them, we're here, let's just go, let's get started. And I'm falling much more on the let's just get started. They can catch up when they get here. So that being said, if you are in the back and want to stay in the back, that's totally cool. I'm going to put some stuff up here on these slides and in a terminal, and you're going to need to type some of the things that I put up. It's not going to be a ton of typing, but you will have to do some typing. So if you want to move closer, you might be able to see better. But it's probably going to get about as small as, say, like this. If you can read that, like, from where you are, then you're probably fine. Can you read that from where you are? Yeah, everybody can read that? Yeah, cool. I don't want to make any, I don't want to be prejudiced against your eyes. I don't know how your eyesight is. I know mine is terrible, so I make it big. Right, but enough about my home directory. Let's go back to some slides. So as you're coming in, we'll do introductions. Yeah, so my name is Nathen Harvey. I'm the VP of Community Development at Chef, which means, for the benefit of everyone, none of my code runs in production. Yes. So also, I am no longer in control of any production systems. So the world is a much safer and happier place because of that. With me today, helping out, I have Nicole Johnson, who I'm going to let introduce herself.
Hey, everyone.
Yep, good.
Nicole Johnson. I've been with Chef for about 2 years and helping out Nathen teach this class. So I'll be kind of wandering around the room, helping out if folks need help.
Awesome. And the first and maybe most important duty that Nicole has is she has a stack of random numbers. Everyone must have a collection of random numbers. You need one collection of random numbers. You might recognize what the numbers represent when you see them. You might even be able to guess. All right. And it's like, you also don't need it on the next slide. Like, you don't need it immediately. That's not the first thing we're going to do. I'm going to talk with you for a little bit before we jump into the typey. So I would love to know a little bit about you also. So I'm going to ask a couple of questions. I'm going to ask you to raise your hand. These are kind of self-identifying questions. No one is going to do any research to figure out if you told us the truth. You're allowed to answer as many of these positively as you like. So I just want to know, how many of you consider yourselves developers, like software engineers? You build applications. Okay. And then operations people, like we run the applications. Okay. Awesome. How many of you consider yourselves a DevOps? Okay, I don't know what that means, but that's cool. That's cool. You can consider yourself that. There's no judging here. How many of you consider yourself a business person? All right, there are 2 people in this room. You should keep your jobs. Everyone else, you should quit your job. Because if you don't care about your business, then you're probably not a business person, and why do you work there? You should care about the business that you're in. If you want to really be a DevOps, what it really means is giving a shit about your job. And if you give a shit about your job, I don't know what your job is. It is not to rack and stack servers. Even if you're a sysadmin that runs a data center, that's not your job. Your job is to make your customers happy and understand who those customers are. All right. None of that has anything to do with application automation with Habitat, but I did want to kind of suss out, how do we fit in this room? Are we developers? Are we operations? It feels like we're a mix of both. Some of us have identity crises that are working, and that's cool too. So I have an agenda, and you're welcome to read this agenda. I'm going to talk for about, or we're going to do things for about 45 minutes. It may follow these timelines. It may not. We're going to do things as they come. I welcome and encourage any questions that you have. I'll tell you something that's true. I know what is on every one of these slides. So I know all of the words that I have prepared to say, and I'm going to say them. It gets way more interesting for me when you ask questions, because that helps. That helps me think and helps me learn and helps Nicole as well. So if you have questions, you can ask them. One question you might have is, where can I get the slides? And the answer is later, which I realize it isn't a where, it's a when. But we're not going to give you the slides at the beginning of the workshop, but we will make the slides available sometime shortly thereafter. So, yeah. So some of the goals that I have for us for the day. I want you to be able to describe Habitat. Like, what is this thing called Habitat? How many of you have heard of Habitat before you walked in the room? Okay, that's good. That tells me you're probably on the right flight. And how many of you have used Habitat, done anything with it? Okay, good, good, good. So I'll tell you what, when you're teaching a workshop, it's always best when there's very few people that have used what you're teaching, because then when I lie, you don't know. You believe me, you trust me, it's good. So I want you, by the end of this, to be able to talk a little bit about Habitat, what it is. We're going to go through and run an application with Habitat. I'd love to have you join the Habitat community, and I'll talk about just exactly what that means. And then throughout the workshop, throughout the rest of your life, I want you to share your experience with Habitat. These next 45 minutes are going to be so life-changing that you're just going to want to go and tell everyone about it. I'm pretty certain that that's not the case. Okay, so Habitat. Habitat is this thing by Chef. And I have a question for you. Why do we run infrastructure? Why do we do that? What's that? For paychecks. Paychecks. That's a great reason to run infrastructure. Yes, I run infrastructure so that I can get paid. That's good. You run infrastructure because you have to follow regulatory compliance. So someone comes in and says, yo, the cloud is not safe. Don't put my data there. Yeah, keep it on infrastructure. Cool. Because you need it to do other things. Our job is not to run infrastructure. Our job, like the reason we run infrastructure, is to run the applications that support our business. There are about, I'd say, 40% of the people in the room that, like, if you went off, one of you or a team of you went off and built the most amazing data center that was fully automated and did really cool stuff but ran no applications, there are about 40 other people in this room who'd be like, yeah, that is badass. But no one else in the world will care, because there's no applications that run there. Some of us, like we sysadmins at heart, we're going to care about that because that's awesome. At the same time, all of you developers that have applications that run on your laptop, yeah, that's great. Like, how many people are you going to get around your laptop to buy services off of the thing that you're selling on that site or on that application, right? Your applications have to have some infrastructure, and the reason that we build this infrastructure is so that we can run applications. And that's really what Chef is all about. So Chef, you may know Chef as like the configuration management tool. You may think of Chef, maybe because we've said this for about 10 years, as a platform for infrastructure as code, infrastructure. Because infrastructure is our jam, but we're really now kind of shifting and thinking about applications and talking about how do we run our businesses, what do the customers care about, and it's those applications. How many of you, just a quick show of hands, now that there's more of you in the room, have used Docker? All right, awesome. And Docker in production? All right, awesome. And what like platforms are you running it on? Kubernetes? Yes? Kubernetes? Docker Swarm? Yeah? A little bit of ECS? Mesosphere? Anyone using Mesosphere? Yeah? Okay, cool. Did I get them all? Somebody else? Who built your own little orchestration platform for Docker? No? Yeah? Yeah. Cool. Our applications have changed over time. How many of you right now have a monolith application running in your environment? Yeah, it's awesome. This monolith looks pretty simple, actually. Like, there's this one big application that's talking to one data store in the background. I don't know about you, but I've definitely been at places where we took two big monolithic applications and said they should share a database. And not only just share the infrastructure that was the database, but like, let's share schemas and like share data that way. And that's super fun, and it makes for great development life cycles and everything. It's terrible. Of course, we're changing. We're now all running microservices. Who isn't running microservices? Some form. Yeah, a couple of folks aren't doing anything with microservices. But man, you want to, right? It feels like the right thing. Like all the cool kids are saying microservices, and some of them even saying it with Docker. But with microservices, of course, what we're doing is we're breaking down those applications. And there's some really nice things about that, right? Our development teams can start to work a little bit more independently. We can have smaller development teams. We can ship smaller changes faster. We can break things much faster, maybe. But we want to sort of move into this space where we can sort of adopt modern infrastructures for our applications. How about serverless? Who's doing stuff with serverless? Yeah, a couple of people. That's awesome. Yeah, we're not really going to talk about serverless today. I'm not even going to bash it because I think it's cool, whatever. But as our applications are evolving, we're really moving from this idea of centralized applications. We're really sort of blowing them up, spreading them everywhere. And of course, one of the things that this means is that our applications just get more and more complex, specifically in the operational environment. So if I'm running one big application, it's very easy for me to reason about that application, for me to think about that application. How do I manage that application in production? What does that actually look like? But when my application turns into 200 microservices, the operational complexity really goes up on that. And you really have to start thinking differently about your applications. And so hopefully what we're doing is making smarter applications, because as humans, like, we can't keep that 200 microservices in our head. We're moving away from a place where we have all of these large artifacts into thousands of small artifacts. If you look at a Docker container, it's much smaller than a piece of hardware, right? And so we have all of these artifacts that we need to manage and coordinate over time. And as developers, this is what we need, right? This is our jam. There's new frameworks coming out all the time, especially if you're in like the JavaScript world. There were 3 new JavaScript frameworks launched this week. Did you know that? It's Wednesday, right? So there's only 3 launched this week so far. But there will be more, right? This is what developers need. Actually, it's probably not what they need. It's definitely what they want. And this is what they end up building, right? So I'll just give you a minute to sort of take that in, right? This because shiny and new and framework, and let's go do that thing. Let's play with that. Let's put it into production. And this, frankly, from an operations perspective, it gets pretty terrible pretty fast. How many of you on the operations side have been nervous when the development team comes to you and says, hey, I want to try this new application. I want to get it. Yeah, of course, all of us, right? Yeah, it's terrible. And we have this real problem with application management, right? As we start introducing new frameworks, maybe you're a Java shop. And then someone comes in and says, we want to start building Node applications. Now you have to think about all of that tooling around a Node application that's different than a Java application. How do you package up a Node application? How do you take that Node application and deploy it into your production environment? How do you get the Node application updated in your production environment? How does all of that work? And as operations folks, and even as developers, we have to take on all of this additional complexity with every new framework that we bring in and so forth. We also, as we move from a thing like a monolithic application into microservices, we have to start bringing more tools to bear. We have to bring in things like service discovery. Where is the database? Where is the upstream API that I'm calling from? What other APIs are available to me, and where do those things exist? All of this just becomes more and more operational overhead. But with any of our software, we really follow this process. We have to first take our application and turn it into some sort of artifact. So we build an artifact. We then deploy that artifact, and we run that artifact in our operational environment. So you have a build, a deploy, and a run. And depending on the framework that you're using, like, it's going to be very different in each one of these. How many of you use or work on Rails applications? And how do you turn those into artifacts? Yep, I don't know either. I don't know either, right? Like, building a Rails application and creating an artifact out of it is not, like, it's not common practice. It's not common practice for you to do within the Rails environment. But how many of you run Java apps? And how do you build an artifact from a Java app? Yeah, you create a jar, like you have real artifacts. It's like a grown-up framework. It's not this kiddie framework of Rails. I love Rails. I have a lot of background in Rails, which is why I feel like I can bash it for a minute, maybe. And as we put these applications into our operational environment, we have all of these different concerns, all of these operational and runtime concerns. So first, application supervision. Is the application up? Is it running? What happens if the application falls over? How does that application get restarted? You have service discovery. Where are the various endpoints that I need to go and connect to? Those endpoints might be a database that I need to connect to. It might be some external payment gateway. It might be some serverless thing that I have to connect to. But I have to have all of this service discovery somewhere. My application configuration, if I build an artifact, I want to be able to take that artifact and run it in all of my environments. It doesn't make sense for me to build an artifact, execute my tests on that artifact in a QA environment, but then have to rebuild that artifact for production, right? Because if I rebuilt it, how valid are those tests? They're probably fine. Everyone saw Pete's talk this morning, right? It's all probably fine. Oh, it failed in tests, but we're just going to rebuild the artifact and push the new one to production. That's even better, right? But we have to have ways to configure those applications. We also have to think about the topology of our applications. If you think about a very simple topology example, think about running a database. How many of you run MySQL? And how many of those of you run just one instance of MySQL? Like a single instance. There's no replicas, there's no, slaves or followers. Yeah, nobody. How many of you run Mongo? Yeah? Do you run one instance of Mongo? No? So you don't believe the hype when they say Mongo will just throw away your data. Or you do believe it, and so therefore you don't run just one Mongo, right? We always run multiple instances of applications. So in a database example, right, we have to configure our database in such a way that we have a leader and some followers. And these leaders and followers, like, one way that we can do this today is we can actually build different artifacts. Like, this is the artifact that is the leader database. This is the artifact that is the follower database. And make sure you deploy enough of those. But then what happens when that leader disappears? Do I have the right artifact running? Do I have the right application running? And also, how do you handle things like quorum? How do you handle leader election? Who should be the leader? If all three of us are running, who should be the leader? Like, we have to answer all of these questions in production. We also then have updates. Like, I'm pretty confident in saying that none of you have deployed a version of an application and been like, yep, that one's done. Let's move on to the next one. We're never going to change that application again, right? We are always constantly updating our applications. And then there's that big topic of orchestration, which we have 45 minutes. So I'm just going to say the word, and I'm just going to move on. Orchestration. And man. All right, so what is this thing called Habitat? So Habitat is used to build, deploy, and manage applications. And you can build, deploy, and manage those applications in any environment, from your traditional data center all the way through to containerized microservices. So if you're running in containers, you can use Habitat. If you're running in a physical data center, you can use Habitat. And what we're going to do over the next however many minutes, 26 minutes or so, is we're going to run an application with Habitat so that you can get sort of the feeling and see some exposure to what it means to run an application within Habitat. And the application that we're going to run is called the National Parks application. It's a relatively simple application. The way the application works is cool, I guess, but it's not really the topic of the course. It's really about how do I run this application. So this application itself is a Java application that runs in Tomcat, and it's going to be deployed on MongoDB. So when I asked how many of you have run MongoDB, there were like 3 hands that went up. And within the next 20 minutes, everyone will be able to raise their hand. You've all run MongoDB, so I'll even certify you on it if you like. Yeah. Okay, so it's going to, when we're done, we'll know we were successful when you can go to a browser and point at your machine, and this is what you see. I also like to put this map up because if you've not visited all of our national parks, I think someone is after them. You should go visit them now. So make this your bucket list. Go visit them as quickly as possible. All right. So what I'd like you to do is go ahead and log in. So this is on that little piece of paper that Nicole gave you. And if you didn't get a little piece of paper from Nicole, now would be a good time to raise your hand so that we can get you a little piece of paper from Nicole. And I might even help. Do you still have some? Yeah. All right. I'm going to go to you. Oh, yeah, take one. You can't ping it? Oh. All right. So I want you to SSH into your machine. You're going to log in with the username chef and the password chef because security. Yes? It's not working? Is anyone able to log in? All right. That's cool. We have plenty of little pieces of paper. It's the cloud. If it's not working, throw it away and get another one. That's what we do, right? Okay, so I'm going to do the labs right along with you. I know some of you are still waiting for an IP address, but if you're confused or need some help, you can watch what happens up here. I'm just going to talk you through some stuff. So chef, SSH chef at my IP address. If you're following along, you should not type my IP address. You should type your IP address. And the first thing that happens is it asks me to verify the authenticity of this host. There are enough sysadmins in the room here that I think you can tell me how to verify the authenticity of this host. How do I do so? Type yes. Excellent. You get a gold star. YES, enter. Okay. And then it asks me for my password. And what's my password? What's your password? All right. See, social engineering is the thing that you need to worry about when it comes to security. I just got you all to tell me your password. Now, here's the other thing that you have to be worried about. Your neighbor. They might look over your shoulder and look at your IP address and say, hey, I think I want to mess with that person sitting next to me, and I know their username and password, and I can SSH into the machine. So let me tell you a little bit about these machines that I've just given you. First, they're cloud instances. You can use them for anything you want during this lab as long as you do only what I ask you to do during the lab. And if you break one, we got a stack of them. We'll just throw another one at you. It's totally cool. I would prefer it if you not do any Bitcoin mining over the next 20 minutes or so. Well, I mean, you can do that, just not on, I would prefer it if you didn't do it on these machines. Let's see. Also, these are horrible, horrible machines. And you know that they're horrible because first you were able to just SSH in with a username and password. And you should never, ever, 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 ever be able to do that. But don't worry. We're going to make even more egregious security failures later. Like, we are going to just break a lot of shit. If you want to poke around on the system, you'll see that you're logged in as the chef user. Not only can the chef user log in just with credentials via SSH, but also has full sudo privileges, even passwordless sudo privileges. So this box is yours. You can do whatever you want with it. I don't know why I remind people of that at the beginning of every workshop. Like, I probably should stop doing that. But I feel I should be, honest, tell you what's going on. Maybe we can run this command, hab -- version. And this will tell you what version of Habitat is currently installed on those systems. And hopefully what you see is that it's version 0.26.1. And then there's some build number after it that looks suspiciously like a date timestamp. Okay, has everyone been able to log in to their machine successfully? Yes, except no. Okay, if you're no, just make sure Nicole comes to help you. All right. This gets a little bit trickier. So you've logged into the machine. That was maybe the hardest part. I need you to be logged in 2 different shells. So do you think you can do it again without me showing you? Well, you can watch me if you want. But I need you to have 2 windows open where you're logged in as that same chef user. You can use tmux, yeah, if it's on the box. It is on your box now. Listen, you can use tmux as long as you installed it with Chef. Okay, if you're a chef, then it's fine. Right. So one time I was teaching this course, and I had published the list of IP addresses, and I gave it to everyone in the room. And I went to my home directory as I'm going through, and I'm like, oh, let's just do an ls -a. And there was a .ansible directory because someone had all the IP addresses, so they just ran Ansible against all of the machines for me. It was a little super awkward, but it's cool. I clearly I'm carrying it with me today, so I felt the need to share it with you. Right. Let's see, where were we? All right, so we've logged in. All right, I want to talk quickly about modern applications. So we use this phrase like modern applications for modern application teams. That's what Habitat is for. A modern application, really we're kind of moving from those monoliths to those microservices. But any modern application starts first here in a source code repository. So tell me, what source code repository do you use? Git. Bitbucket, which is Git. GitLab, which is Git. That's good. What else do you use? SVN. Okay, that's cool. Perforce, also cool. TFS. All right, cool. Listen, for a modern application, my preference, and I hold it strongly, but again, I don't run any code in production, so you don't really have to listen to me. Like, there's one criterion for what makes a good, proper version control system, and that's that it starts with GIT. So as long as you're using Git SVN or Perforce Fusion, I think is their Git plugin, like you're totally fine. You're good with all of that stuff. I don't know what the TFS Git thing is, but I'm sure there must be some sort of Git integration. And how many of you in the room are still using the BAK version control system? Yeah, yes, yeah. You all know that one, right? Everyone knows that one. Copy a file to filename.bak and then update. Yeah, okay. That's not a version control system. Please don't do that. Okay, so applications. We write code, we put that code into a source code repository. From that source code repository, we create an artifact. Unless we're running Rails apps, and then we probably can just skip this step. And then we take that artifact and we put it into an artifact repo. So that's where our artifacts live, maybe something like Artifactory or Nexus. And then from there, we should be able to run our artifacts anywhere that we want. Now, for the purposes of this very condensed workshop introduction to Habitat, we're going to start here. So the artifacts already exist. We're going to skip the whole build process. If there's time at the end, I'll either demo it or answer questions for you, or I'll stick around after and do both of those things. But I want to get to the how do we run applications with Habitat, because I think that's where a lot of the really cool features exist and the things that we have to care about. So I also want to tell you that in these labs, I've intentionally put in some failures, because I think failure is a great way to learn. And so when things break, this is really just a disclaimer. When things break, it's because I meant them to break. It's not because I fucked up. It was an intentional pitfall. It's a learning exercise for you. That's why they break. I'm sorry if my cursing offended anyone. I won't promise to not do it again, though. Okay, so there will be pitfalls as we go through. All right, so your job is to start up this national parks application. It's a Java app. It sits on top of a Mongo database. With Habitat, what we care about most, the way that we approach these problems, is we start with the application first. You shouldn't care what infrastructure it's running on. Of course, you're running on a piece of infrastructure, a cloud instance that I've given to you. Also, we give that to you because in 45 minutes, I couldn't troubleshoot the installation process for all your corporate laptops. Okay, if I wanted you to install something, right? So the first thing we're going to do with Habitat is we're going to start the supervisor. So in one of those two windows that you have, I want you to start up the Habitat supervisor, and in a second, I'm going to tell you how. That's not the slide I expected. So what is this supervisor? The supervisor is the thing that's going to keep your application running. So a supervisor is responsible for starting up your application. If your application falls over, it's going to restart your application. We'll see that it also does a bunch of other things for us. But for right now, it's going to install the application, and it's going to keep it running. So I want you to run this command, sudo hab soup run. And it's soup, not like, you eat the soup because soup is delicious, which is weird because it's from chef, and so you'd think we'd call it S-O-U-P. But it's soup for supervisor, so sometimes you might read that and say sup, and you're wrong because it's supervisor. It's shortened, so it's soup, okay? You can say whatever you want. I don't really care, as long as you type the right command. Also, I didn't mention this earlier. Thank you for sticking around to the very end of the conference for a little workshop. And I hope I'm not too punchy for you, but I do hope you stay awake, and maybe we're having, hopefully, just a touch of fun. All right, so I'm going to do this same thing over here. if I can remember how to navigate my computer. So here I am in this window. I'm at the top. I'm going to run sudo hab soup run. Thank you for watching me type, because then I type better when I type. Also, as I type and run commands, before I run them, you may notice a typo. And at that point, you have two choices. You can correct my typo, or you can just wait and laugh, right? Because I will fail. OK, so what just happened? I don't know. I don't know what just happened. It doesn't matter. I'll tell you what happens. But we're just going to let that be for a minute. So we've started up a supervisor. So our supervisor is responsible for installing applications and running those applications for us. So the next thing that we want to do, because what we're doing is we're running an application, is we actually want to start up our Java application, the National Parks application. So not in that window, now in your other window, and your other window is where we're going to do everything else. But you want to just keep that supervisor window there so you can see the output of the supervisor. But I want you to run this command, hab soup load learn / national -parks, or dash parks. I don't know if that's a hyphen or a dash, and I don't care which you call it. And I'm going to do the same in a second after I wait for you to finish typing. Did that work for you? Yeah? It's working. OK, great. If it's working, that's good. OK, so I'm just going to switch my windows. OK, so now if you're looking at my screen, my supervisor is just running down here. That's the supervisor. And now I'm going to run my other commands up here. So what did I tell you to run? Sudo hab soup load learn national parks. OK, so that's going to start launching stuff here in the background. And I think I'm going to keep talking while it does, because all right. So there is a pitfall here. But yours maybe has already failed. Mine hasn't failed yet. So in your supervisor output, you might see at the end here, missing required binds to the database. So this is a Java application that runs on top of a database. We didn't tell the Java application when we started it up where to find the database. We didn't bind it to a database. So we need to fix that. So in order to fix that, the first thing that we're going to do, that's our pitfall, is we want to get the MongoDB service running. So our supervisor is sitting there. We just said, hey, load up the National Parks app. It tried to load it up. It said, hey, you haven't given me enough information to start this application. You need a database. So now we're going to ask the supervisor to load the MongoDB database. So we're going to run this command, sudo hab soup load learn / MongoDB. And this should very quickly just start up a MongoDB for you. All right. What if I told you this EC2 instance is production? There, now you've all run MongoDB in production. Congratulations, way to go. Let me go ahead and do the same with mine. Let me come back over here. So here, sure enough, I have that same error, missing required binds for database. In my window on the top, I'm going to do sudo hab load learn MongoDB. Yep, I sure do. You can also correct me, let me ignore you. Yeah, yeah, wow, that's so good. You're so kind. OK, so MongoDB has started, and in our output at the bottom, we see MongoDB default, and we see a note that no pre-alloc may hurt performance in many applications. But you know what? We don't care. We don't care. It's totally fine. It's probably fine. It's only prod. It's MongoDB, so I'm sure it's fine. All right, so our our database has started. But this raises a question, right? The National Parks app did not exist on this box when we first ran the hab soup load National Parks app. If you look at some of the output, you probably saw it was downloading packages. So where did these packages come from? Well, they come from an artifact repo. So remember back to the way modern applications work, start in a source code, end up on a system. So This depot is something that we currently publicly host as part of our Habitat ecosystem. So on the Habitat website, this depot exists. And anytime you build a Habitat package, you can publish it to that depot. Now, soon, we will have the ability for you to run your own private depots as well. And when you want me to clarify that word that I used, soon, you probably want to know, like, when do you mean when you say soon? I will remind you that I am a software vendor, and if I tell you the date that something is going to ship, if it's in the past, you can totally believe me, right? Right? So it is going to ship soon. I don't know when soon is. It should be this fall. But I said this fall. I should have said in the fall. That would have been better. Yeah. And I didn't say whose fall, like whose autumn will it be. I don't know how that works with the southern hemisphere. Like, have they already had their fall? Am I already too late for anyhow? All right, so this depot, it sits out there. And so what just happened, I told you we were going to do more crazy security things. What just happened is we went out to the internet. We went to some publicly hosted artifact repository. We downloaded those artifacts and we ran them. And remember, this is in production, right? So that maybe feels a little uncomfortable. It's cool. I agree with, and yes, your uncomfort is warranted. So, but if you went to app.habitat.sh or just habitat.sh and clicked on Explore, you could see all of the packages that are currently available and that have been published, and we don't have time to go and dig a whole lot into that. Okay, but we now have our database running. We told the supervisor to load our Java application, but it's in a really weird state. So the next thing we want to do is we actually want to take out the Java application. So the only thing that the supervisor is running at that point is the MongoDB. So we run this command, sudo hab sup unload learn / national - parks. I'm going to do the same really quickly. All right, so now I've unloaded the national parks. We're good there. Well, we've completed that step. Who knows why we did that? We did that so that we could reload national parks. And I'm giving away a hint that this is going to fail a little bit, but we're going to expect and embrace this failure. So what are we doing this time? This time we're going to change the way that we started a little bit. Sudo hab sup load learn / national - parks -- bind. So remember, when it failed to load, it said, I'm missing a bind for database. So we're going to bind to this keyword database, and we're going to point the database, point with a colon, to mongodb.default. So if you remember in your supervisor output, you saw lines like that no pre-alloc will cause performance problems in some applications. It started with the words mongodb.default. So the way that our supervisor works, when it loads up a service, so in our case, the MongoDB service or the National Parks service, it will take those services and put them into a service group. And so by default, it will use the default service group. So we're saying it's the MongoDB service running in the default service group. And we want to point to that. Now, in this particular instance, I've given you one machine. And so this is doing service discovery. It's finding the local MongoDB. So it's a kind of a wonky, like, cheating way to do service discovery. But the cool thing is we don't have to know where that MongoDB actually exists. As long as I'm talking to another supervisor, I can find that MongoDB. So that's how Habitat does this service discovery. Now, when you do this, let me go ahead and do this also so that we can all be on the same page. So sudo hab sup load learn national parks. If I didn't say what I was typing, it would be easier. And if you would stop watching, it would be easier also. Database mongodb.default. Okay, now on the bottom, this is going to start loading. But if you look at this output, it's kind of stuck. this output is stuck in a loop. And it maybe scrolls by a little bit too fast for you to read, but it's okay because I built slides so we can read it as slow as we want. It can't connect to the database. So it's telling us National Parks is trying to initialize. The way that this application initializes is it connects to the database and it loads all of the data into the database. And then the application is ready to go. Well, it can't connect to the MongoDB. So think about most applications, when you start them up, if they're missing things, like I can't connect to the database, that application is just going to crash. Well, the supervisor doesn't want our application to crash. It's going to keep that application running, and it's just going to keep retrying. It's going to keep retrying until that database becomes available. Now, we know the database is running, but for some reason, we can't connect to it. And the reason we can't connect to it is because you aren't MongoDB admins, and you've configured your MongoDB wrong. But it's OK. I'm here to help. So we're going to fix that. So the thing is, when you're running MongoDB, we have to change some of its settings. We have to change some of the configuration parameters to allow our application to connect to that database. And so when you're running your own applications, how do you know what the tunables are? What configuration parameters are available for that application? How do you figure that out? You read the man page. You might read the README. Maybe the developer documented it on the wiki. Do you trust any of those things? Me either. Probably. Maybe the man, no, probably not. So one of the things that we can do with Habitat that's pretty cool is we can ask the supervisor to interrogate a package and tell us what the configuration parameters are. So if you run this command, sudo hab sup config learn/MongoDB, this will tell you the configuration, the default configuration of the MongoDB package. And it just spits out a bunch of stuff that's the configuration. All of the configuration doesn't matter a whole lot. What we're going to do is we're going to run that command again. So if you hadn't finished typing it yet, it's OK. Like, I'm having you run the same command. But this time, I'm going to have you redirect the output into a file that we're going to call mongodb.toml. Nicole, what time do we go till? Did we go till 4 or 4:30? 4:30? OK, good. Whew. I was going to go really, really fast for the next 2 minutes. Sweet. Did you all type this? Did you create a mongodb.toml? OK. Now, maybe this is the hardest lab. I need you to edit that file. So what editor will you use? This is as bad as that question when I asked about your version control system. You're right. There's only one editor. Right. Which one is it? Emacs. Right. Yeah. Yeah. So how do you know an Emacs user? They'll tell you. Exactly. Yeah. Exactly. That's exactly right. Yeah. And Tim's an Emacs user, so he knows. Yeah. All right. So I need to get caught up with you because I'm far behind. There's my thing just in a loop over there. Oh, I didn't want to do that, but that's fine. All right, now I'm typing on the bottom pane there, sudo hab sup config. Tell me the configuration of, what do I want to know? Learn MongoDB. Does that look right? Yeah? Looks like it did something, or nothing, I don't know. So this is really cool because one of the things that's great about containers, as an example, is as a developer, I can shove all of my shit into a container and then just hand it to ops and say, just run this thing. And that's awesome. But ops kind of maybe wants to know, what are the tunables? What are the things, what are the configuration parameters that I have control over? So this is a great way to expose that because the supervisor will tell you exactly what's available there. So I'm going to get judged because of the command that I just typed and open up my mongodb.toml. We're going to, sorry, I can't, I just want to say this before we change anything. You should never, ever, ever, ever do this again, what we're about to do. Because what we're about to do, the reason that we can't connect to the MongoDB is because it's configured to listen only on 127.0.0.1, and it's configured to only allow authenticated connections. And so what we're going to do instead is we're going to tell Mongo to listen on all available interfaces, and we're going to tell it to accept connections from anyone from anywhere. Okay? So I understand those of you that run Mongo in production, you've already done this, but I'm here to tell you it's wrong. Don't do that. So I'm going to show you how we can break Mongo and just do a terrible, terrible thing, but you should never do this again. Do you have a question? Okay. Good, because it's all seriousness in this room. There's no... Okay. Okay, so in that MongoDB TOML, there's a ton of different configuration settings. You can trick out your MongoDB however you want. What I need you to do is near the top, you'll find it's probably line 2, the bind IP. We want to change that from 127.0.0.1 to 0.0.0.0. And after you've changed that, further down the file, these 3 dots just mean, you know, there's some stuff in here that I'm not showing you. You're going to find under MongoD.security, in that stanza, you're going to find a cluster auth mode, and it says key file, which means that we have to have this pre-shared key file in order to connect to the MongoDB. But we're just going to remove that word key file, and we're going to set the cluster auth mode to an empty string. So we've turned off authentication, and we're listening everywhere we possibly can. Come on in. Take me down. I mean, take my data. I mean, whatever. Fix this National Parks app. Okay, I'm going to make the same changes. That would be, I think you need Emacs for that. That's the problem. I'm a Vim user, and so, like, yeah, I just use my arrow keys. Okay, so write that file. And, oh, I forgot. I think maybe I forgot something. Yeah, I did. If editing a file in a command line editor like Emacs or Vim or Nano isn't your jam, and that makes you super uncomfortable, that's fine, and I'm not judging you at all. There's a new -mongodb-config.toml. You can just rename that file, and then the changes are made. It's not funny. It's not funny. There was a time when you didn't know how to use a text editor. Oh, come on. All right. Everyone's edited their file. So we're going to do this next. This is the thing that we're going to do next. We're going to remind you to never do this at home. So back to those supervisors. In addition to that supervisor installing things for us and keeping those things running, they can also help us manage the configuration of our running applications or of the applications we're about to start up. So we're going to run this command. Now, I'm going to talk you through this command. I'm just going to put it up here for right now. But before you start typing, I just want to point out one thing, maybe more than one. At the end of this line, this sudo hat, can you read that in the back, by the way? Yes? OK, great. At the end of this line, there's a backslash, and then we move down to this other line. Like, you don't have to do that. This is really just one command, but it's too long to fit across the slide and still be legible, which you could argue it's still not legible. So just one line. You don't need that backslash there. And I would prefer it if you just type it, but not hit the magic key yet. You know which is the magic key, right? It says enter or return on your keyboard. Yeah, just don't do that yet, because I want to just talk through what this command is doing. You have a question? Yes, I will show that to you. Now everyone's like, no, bring it back. Under MongoD.security, the cluster auth mode, we changed that from key file to just an empty string. You bet. OK, so do you have this command that I took away from you while you're in the middle of typing it? Have you finished typing it yet? Yeah? OK. Let me just talk through what this is going to do. And here it is again, now on one line for your convenience, but I want to talk through each part. So sudo hab, so we're using the habitat CLI, config apply. So we're going to apply a configuration change. Now, in order for us to talk to the supervisor, we have to give the habitat command line interface a peer to talk to. So this is one of our supervisors. So I want you to just imagine in your mind for a minute that we're not running a single MongoDB and a single Java app. And even if we were, imagine that they were on multiple machines, right? There's the Java app over here, there's the MongoDB over here, and probably it's a cluster of Mongo servers, and probably there's a bunch of Java application servers. Well, if we want to change the configuration of Mongo, each one of those services, the Mongo service, the Habitat service, they're all running under a supervisor. So if we want to inject a configuration change, we just need to point to one supervisor. It doesn't actually matter if this supervisor is supervising MongoDB, as long as it's in that same group, that same service group. Remember, we're in the service group default right now, so if you're in the default service group, we just talk to any supervisor. So we have to point to a peer, and that's what we're saying. One of our supervisors is just available on this local host, 127.0.0.1. Now, this configuration change is targeting this service, the MongoDB service running in the default service group. So that's who we're updating. Next, we have this number 1. The number 1 seems just odd. It is the incantation or incarnation of this configuration. And so the way that this works, let's say that we have multiple people, or over time we're going to inject multiple configuration changes. You cannot inject configuration change 1, then inject configuration change 2, and then inject configuration change 3. Like, all of that works. But then if I come along and say I want to inject configuration 2, it says, no, 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 you're already past 2. The incarnation that I'm on for configuration is number 3 right now, so you can't go back. There's no such thing as a rollback. You have to roll forward. So the supervisor enforces that for you. Is there a place to see latest? Yeah, I'm sure that you can inspect the supervisor to see that. That's a super solid answer, isn't it? Yeah, I'm sure you can do that. Why not? Yeah. Just like check the source code. I'm sure it'll tell you exactly where. Yes? One of the supervisors, yes. Exactly. Yes, that's exactly right. And then the last thing that we're giving it is our configuration file. So this is the new configuration that we want applied. Now, when we actually change the configuration of a service, we can do that a number of ways. We can, at startup, we can set environment variables that would change the configuration of a service, which you maybe are comfortable with or have experience with if you're running 12-factor applications or even some Docker stuff. We can obviously inject it like this. We can also write a user.toml in a specific location for that service. So I want you to go ahead and hit enter on that change. And what you'll see in your supervisor output is that it's going to apply that configuration. I need to go and type that configuration myself. So let me do that. Sudo hab config apply -- peer. One. Is that right? Yeah? All right. I trust you. I hope you're right. Okay. So it's applied my configuration. And what you can see happening up here now is that it actually initialized the database. So Java was immediately able to connect once that new configuration was applied to the database. And it's loaded up the data. And it looks like I've now launched that Java application. So this is kind of cool. The supervisor just tried to keep running that application until the database became available. So if you go back and think about that word that I said we weren't going to talk about, orchestration, like, think about deploying an application. When you go and provision infrastructure for an application or provision the runtime environment for an application, sometimes you have to care about the order, the sequencing of those things. First, we have to make sure the database is there and fully ready before we try to launch the applications. Well, with Habitat, through the supervisor and through the service discovery, the supervisor is going to try to keep that application running all the time. So I can get rid of that sequencing. I can deploy the applications. They're not going to start until they have all their pieces, but as soon as those pieces become available, they will launch. So we're really converging on the policy or the application that we want. It's a convergent system where, yes. Okay, so now the real test is if you go out to your browser and you go to http:// your IP address, not YOUR IP address. And we're running on Tomcat, so it's on port 8080 and /national-parks. If all goes well, you'll have a map with a location of all of the national parks available. Did everybody do that? Yeah? All right. I said when we did this, we would be done. We would know we were successful, so you can leave. Goodbye. Now we can keep talking. It's all good. Because there's a couple other things that I want to show you in the last 17 minutes or so that we have. All right, so let's take a look. Where am I? One more. All right, so Mongo got its new configuration, did its thing. The Java application connected, initialized all the data, so it loaded the data into the database, and then the Java application was able to come up. So when you think about those supervisors, the supervisors themselves are providing this RESTful API. This RESTful API is how the Habitat command injects that configuration into this supervisor. And the way that those supervisors work, so again, it's kind of hokey in this lab because each of us have our own individual machine and everything that we're running just runs on that one machine. In the real world, please don't run your applications like that. Like, spread them out on multiple places. But all of these supervisors just come together and they communicate with one another. They sort of gossip with one another, and they form a gossip ring. But if you're a gossip lover, it's not really a ring. It's more like a mesh, but it's also not really a mesh. It's just a thing. But conceptually, you can think of it as a ring or a mesh or whatever makes sense for you. Someone once offered the word posse, so it could just be a gossip posse here. Like all the supervisors form a posse, and they share rumors with one another, and that's how the configuration updates spread throughout the circle or throughout all of the supervisors. The supervisors also have this ability to self-organize. So they do things like provide service discovery. I just say bind to the database and point to the database group, mongodb.default. And the supervisors will coordinate with one another, figure out which one of you is the mongodb.default. And if you're in a leader-follower topology, which one is the leader who I can send all of my writes to, and maybe who are the replica sets that I could read off of. All of that is built into the supervisor. So we went to our application. That RESTful API is also available to me in a browser. Now, this is yet another of our security flaws. Think about this. The supervisor tells us everything about our application, even allows us to inject configuration into our application. So what should we do? We should make that publicly available on the internet without any authentication or authorization to get to it. Also, you should never do this, but it would be really lame if I had to protect that for this course. So I've totally opened it up. So if you go to your IP address on port 9631, go to your IP address, port 9631, and then you can go to something like /services. I'm going to do the same, so let me just hop over to my browser. I'm going to grab that. I'm going to go over here, 9631/services. And it's going to show you, you can read that in the back, right? I can't read it right here. So I'll make that a little bigger. Does your output look like this? I went to 9631/services. Your output might not look like this if you don't have a JSON viewer plugin in your browser. It'll look like just a beautiful page of unstructured JSON. And that, but if that's what you see, actually I know the way that you're reading it looks kind of like this. I see the mental model that you have. So here we can see the various service groups that we have running. So I have a service group, MongoDB, .default. There's so much information in here, including the full Mongo configuration. There's probably the national parks. So there's another service group, the national parks default. I guess I could collapse those a little easier here. So there's two service groups, one for MongoDB and one for national parks. Another thing that we can do here, though, that I do want to show you, if you go to @services, so you're at services now, if you go to /services/MongoDB/default. So I want to look at the MongoDB application and the default service group, and then go to /config. You can see here's the configuration for MongoDB, and we can see that new configuration that I injected. The bind IP is set to 0000. The authentication mode is set to an empty string, so you can see all of this stuff. Now, something that's really interesting here is that we see this for the MongoDB. I could change MongoDB in this URL to national parks and see the national parks configuration. It's much simpler configuration. It's just just a port that it's listening on. But the thing that's really nice about this is that we've really changed the operational characteristics of these applications. We operate them all the same way, right? The way that we started MongoDB was the same way that we started a Java app, would be the same way that we start a .NET app, maybe on a different piece of infrastructure, the same way that we would start a Rails app. We also have things like a health endpoint. So within the packaging of the application can be responsible for telling you, am I a healthy instance? And so now I can set up monitoring. It doesn't matter what type of application. I can just go to the health endpoint and build that into my monitoring tools, the things that I'm looking after. This API gives me the ability, of course, to do the injection of configuration changes, all of that good stuff. There's a lot of pretty cool features there. So we saw that. So with Habitat, we're really addressing all of these runtime concerns. We have application supervision, we have service discovery, application configuration, the topology we didn't really have time to look at. Updates are interesting. So let me talk just really briefly about topology and updates. And I have to apologize because I'm just going to say words. I'm not even going to show you anything. You're going to have to just follow the words coming out of my mouth. So if I wanted to run MongoDB in a way that it was clustered, I would just pass a topology as a command line switch when I run that service, when I run it into or load it into the supervisor, that says topology equals leader. If my topology equals leader, Habitat, the supervisor, knows I need at least 3 instances to form a quorum. Once I have 3 instances, I'll then perform a leader election, and then we'll have a leader and we'll have 2 followers. And of course, you can add additionals and end up with more followers and so forth. And then the way that updates work, so remember, where did our packages come from? From the depot, right? From the public depot. If you want, when you run your applications, you can also provide them with an update strategy. And the update strategy just says, go and look at that depot and watch that depot. If a new version of this package becomes available, invoke your update strategy. And today we have 2 different update strategies that are available to you. One is all at once. And the all at once makes perfect sense for something like that Java application. As soon as a new version of that Java application is available, just deploy that across all of the running national park services. The other update that we have is a leader update, sort of a one at a time. And what happens there is if there's a new version of that package available, the nodes in that service group will get together and have an update election. Now, if it is configured like a MongoDB in a leader-follower election, there's capabilities built in that will prevent the leader from also being the update leader, which is good. You probably don't want to update your leader first. But we figure out who's going to be the leader. That leader will take the new service or the new package, will update itself, start running that new service, and then we'll report back to everyone else how its health check is doing. I'm still healthy, so it's good. You can go next. You can go next. And so throughout that ring, each one will go one at a time. And so we have these really nice capabilities for that. Orchestration, we We don't like to talk about the word orchestration. We like to push more towards choreography. And the difference there is that we really believe that with Habitat, when you're building the applications correctly, and Habitat helps and has a lot of facilities for this, that what you're building are truly autonomous actors within a system that understand who they're acting with, what other components of the system there are, and how do we converge on the right policy. So things like orchestration kind of go away, and it becomes more like choreography. And if we had, another 90 minutes, we could talk a lot about that. So just because we have about 9 minutes left, I do want to kind of wrap up and then take all the questions that you have. First, this is all open source. It's Apache licensed. We would love to have you play around with it, kick the tires. There's a very active community built around this. So if you want to contribute back to Habitat, you can. One of the things that I didn't talk about is the language that Habitat is written in. If you're a Chef user, you know Chef loves Ruby. But I will tell you, Habitat has no Ruby in it at all. Habitat itself is written in Rust. So if you're a Rust developer, Habitat is a really awesome project in the Rust community to contribute to. Or if you want to be a Rust developer, maybe check out Habitat. Everything else that we write, so the languages that you'll use primarily with Habitat are Rust. But if you're just using Habitat, you probably won't write any Rust ever, just like you wouldn't write any Erlang if you're using Chef. You would write Ruby. So you would write your plans. Your plans are how you package up your applications. Those are written in Bash, unless it's on Windows, and then it's PowerShell. So you write in Bash or PowerShell. We have a templating language. We use Handlebars as the templating language for the configuration files. And then, as you saw, we also use Toml for how do you specify those configuration values. So primarily, you're going to write Bash, Toml, and Handlebars. As I mentioned, we have a great open source community that we'd love to have you participate with. We're in at habitat.sh. There's a community link. You can join the Habitat Slack. So we have this open Slack team. And one of the things that's pretty interesting, so Chef is a company. We're in the business of making money and selling software to our customers. And we have internal engineering teams, and our internal engineering teams communicate on Slack, maybe just like your internal engineering teams do. Our Habitat Slack team has, our Habitat engineering team has stopped having any discussions in our internal Slack and has moved them all to the community-facing Slack. Because it is truly an open source project, we just want to build this together with the community. So I think that's pretty cool. All right, now before you go, you should clean up after yourself. I don't care if you do this or not, but if you want to do other things on these boxes, it's probably a good idea. Let's just unload your National Parks app and unload your MongoDB. So sudo habsup unload learn National Parks and learn MongoDB. And then I will leave you with just these closing thoughts or parting words. You can, and again, I'm going to make these slides available later. I'm not sure where, but we'll tell you. I'm sure they'll get posted on the DevOps Days site or something. So you can join the Habitat Slack team. There's a good tutorial. It's not nearly as funny as I am, but there's a good tutorial online if you want to go through the whole process, the how do you build and package up an application, all the way through to how do you run it. You can explore the packages, explore the Habitat projects on GitHub, and finally, we have a blog, of course, also where we talk about Habitat stuff. Yes?
Mel just wrote a blog the other day, making a leader-follower MySQL cluster with Habitat. So check that one out too.
Yeah, that's a great one. Making a leader-follower MySQL cluster. So if you want to play around with that, this is similar to the lab that we just did in that you don't have to package anything. You'll just use existing packages to build that out. So you could set that up if you'd like. So with that, we have 5 minutes left. I want to thank you for coming out this afternoon and learning a little bit about Habitat, getting a chance to put your hands on. I recognize that, and hope that you do also, that this was, I don't even think you could call this a taste of Habitat. Like, it was a very high level, not very deep introduction. I will be happy to answer any questions that you have, including if you don't want to ask them out loud, you just want to come up and talk to me, that's fine too. So thank you all very much, and I'll take your question. Yes. Yes. Uh-huh. Right. Yeah. So the question there was like, what about apps that really do need to have some scheduling and you have some changes that need to be scheduled? That is good. It's not something that Habitat is going to do for you. So, but you could, of course, like we would push you to some external scheduler to do that stuff. Yep. Yep. You could totally do something like that. So you could use, like, we actually don't have a preference for what you use there. Like, you should use whatever you can. There is not a scheduler, right. Oh, the other thing that you can do that I didn't show you that I will mention really quickly, because I think it was in the description or the title of this workshop, was the word containerization. You can take any Habitat package and you can export it as a Docker container. And in that Docker container, you have your service and the supervisor. So essentially that supervisor is the PID one within that Docker container. And now I can use that Docker container in Kubernetes and Mesos, however you're using Docker today, whatever scheduler you're using, you can just run it there. The nice thing about, say, a Habitat package versus a typical Docker package, I think there are differences in the build process. Depending on how you're building your Docker apps or your Docker containers, you may end up with much smaller containers from a Habitat perspective. It'll be easy to know because if you read the first line of your Docker and it says from Debian or it says from CentOS or from RHEL, I will guarantee you Habitat's going to make you smaller packages that are easier to manage, for sure. Also, if that's the first line of your Docker file, it's probably not the right, you're probably not doing it right. But that, again, like, we're out of time. Thank you.